Okay, guys, today we're going to start chapter 8, which is on waves. It's one of my favorite chapters. Waves is something that is used all the time in your life, but I bet you're not so familiar with them. So we're going to study a lot of different types of waves. Like, for example, an ocean wave here. We'll study what kind of waves these are. Even a little ripple in the pond here is a wave. We're going to study the different characteristics of waves. And then, of course, this is physics. We're going to quantify waves. We're going to put numbers to how fast they're going, their wavelength, and their frequency. And so, please be following along in your Chapter 8 guided notes, and let's get started. So first of all, what is a wave? You're supposed to write down the definition. A wave is a disturbance which causes energy to be transported from one location to another without the transfer of mass. So I'm going to underline a couple of things that I want you to remember. A wave is a disturbance. It causes energy to be transported from one location to another. But the cool thing about waves is that we're transferring energy, but we're not transferring mass. And so one thing that I like to show up here on this rope, if I put this paper towel on one end of the rope, the cool thing about waves is that we can transfer energy without actually physically going there and moving the paper towel. I can move it just by transferring energy from right here using a wave. And so watch this. If you send a wave down there, it transfers what? Energy without transferring mass. And so we can use a wave to do things for us. We use waves to make our lives easier every day. And we're going to study how that works. So there's two different main classifications of waves. So there's two different types of waves. Number one is mechanical. Mechanical waves we're going to study in detail today. The other type of wave is called an electromagnetic wave. And a lot of people just call these EM waves for short, electromagnetic. We're going to spend most of today's lesson learning about mechanical waves. So let's go there. Mechanical waves are produced by a disturbance in a physical medium. So mechanical waves need a medium in order to travel through. So what is medium? The medium is the material through which waves travel. So mechanical waves need a medium, which is the material that they travel through. They can travel through air. They can travel through water or solids. But they need something in order to travel through. The medium moves or oscillates back and forth. That's what causes the disturbance. So the medium will move or oscillate back and forth, which causes energy to be transported from one location to another location. Exactly. If you tap on your desk or knock on your desk, are you causing a disturbance in the solid desktop?
Yeah.
Sure. Is that energy then transported to the other parts of your desk?
Yeah.
Yeah, you can hear it, you can feel it even. That energy is being transferred. And it's being transferred through a wave. Mechanical waves can travel at different speeds. They can move at different speeds. Some are fast, some are slow. They can go at different speeds. Here are some examples of mechanical waves. Ocean waves. Okay? Sound waves. And earthquake waves. What are earthquake waves? What are they really called? Seismic waves. Okay, now let me talk about each one of these in more detail. Ocean waves, what's the medium?
Water.
The water, the seawater, right? Sound waves, what's the medium?
Air.
Air.
Depends.
I guess it does depend. Most of the time when we think of sound waves, it's going through the air. But can it go through liquid? Yeah, can it go through solids? Sure. What about seismic waves? What's the medium? Yeah, the ground, the earth. Right. Sure. Okay. Let's quickly just introduce the electromagnetic waves. This is the other main type of wave. EM waves. Again, it's electromagnetic, so we call them EM waves. Are created by oscillating electric and magnetic fields. So they're oscillating electric and magnetic fields. EM waves require no medium to travel through. They can go through empty space. So that's kind of a big characteristics that I hope that you will remember about electromagnetic waves. They can go through even space. Now let's talk for a second. If you're an astronaut and there's no air in space, right? There's no air. How do they talk?
Radio. Which is with their mouth.
Can they communicate with one another in space?
Sign language.
Yes, they can. How are they doing that?
Radio.
Radio waves. Okay, which is a type of what?
Electromagnetic.
Electromagnetic wave. Guys, if you tried to talk in space, if you took your space helmet off, you would die. But let's just say you stay alive. How come you couldn't talk to your astronaut buddy that's just a foot away?
There's no medium.
There's no medium. There's no medium. There's no air for that wave to travel through. So in space, they use electromagnetic waves. They don't require a medium to travel, which is interesting. Here's another cool part about EM waves. They travel at what speed?
Light.
They travel at the speed of light. Okay, and that's the fastest speed that anything can go. Speed of light. Which makes them incredibly useful. How is it that when the Super Bowl happens like in New York, we can watch it here live? How is that? They're transmitting the signal through electromagnetic waves which travel at the speed of light. So it arrives here basically instantly. How is it that you can text message somebody on the other side of the planet and it gets there in a matter of seconds? It's instantly almost. Your cell phone must be sending out waves. What type of waves? EM waves. It must be electromagnetic waves. We'll talk about all the different types of EM waves here in a second. Okay, here's some examples. Visible light. When you turn on the light bulb, it comes out from the light bulb as an electromagnetic wave. That's what light is. X-rays, when you go to the doctor or dentist. These are very powerful waves that can go through your body, maybe not the bones. And they produce a contrast, right? And you can see your bone structure. But you're just using electromagnetic waves. Ultraviolet waves from the sun give us sunburns. Can't see them, but they're there. Radio waves. Tune in your radio in the car. You're getting those through waves, electromagnetic waves. And then finally, infrared. Infrared is used all the time with remote controls. So your remote control at your house, or this clicker that I have here with this presentation, you hit the button, it sends an infrared wave, and that's how it changes slide, or if you're watching TV, it changes the channel. Kind of cool. We can put these waves to use, and they do a lot of stuff for us. They do a lot of work for us.
Yeah, they do.
All right. We're gonna wait and talk more about electromagnetic waves later in the chapter. What we're gonna do now is study mechanical waves. So there's two main waves. What are they? Mechanical, electromagnetic. We're gonna look at mechanical waves in more detail. We're gonna save the electromagnetic waves for later. Okay, practice problem number 1. It says name two types of waves and list at least two differences between the two. So what are the two main types of waves? Mechanical. So there's mechanical, and what's the other one? Electromagnetic. What's the differences? Let's list a couple differences.
Medium.
Which one needs a physical medium in order to travel through?
Mechanical.
Mechanical needs a medium. What's another difference? What's another difference?
Speed.
The speed at which they travel. Which one travels at the speed of light?
All of them.
Electromagnetic waves. Mechanical waves can go slower. They can go faster, they can go slower. Okay, so there's the two main differences. Okay, now we're going to spend the rest of the day learning about mechanical waves. There's two main types. The first one is a transverse wave. Transverse waves, here's what happens. The particles of the medium move perpendicular to the wave motion. What does perpendicular mean? Yeah, if I draw this line right there and I say draw a line that's perpendicular to that, how would you draw it?
Up and down.
Yeah, it's going to meet this line at what angle? At a 90-degree angle. So perpendicular just means it's at a 90-degree angle. So let's go through that again. Transverse wave, the particles of the medium moved perpendicular to the wave motion. Here's what I mean. This guy is making a transverse wave. His hand is moving up and down. Which way is the wave moving? Perpendicular, which means which way? It's moving out. So it's moving out this way. The wave is going that way. The hand is moving up and down. Okay? So that's how transverse waves are generated, with a disturbance that is perpendicular to the wave motion. Okay, let's contrast that to the other type of wave, which is called a longitudinal wave. Like it says here, in longitudinal waves, the particles of the medium move parallel to the wave motion. So here's an example of a longitudinal wave. This guy has a slinky. The hand is moving left and right. Which way is the wave moving? Left and right. They're parallel. They're in the same direction. So longitudinal, same direction. Transverse is perpendicular. Okay, let's look at them in a little more detail now. Transverse waves. Remember, there's two types of mechanical. There's transverse and longitudinal. This first one is a transverse. In transverse waves, the medium moves up and down while the wave moves horizontally. So moves perpendicular. Couple of parts of a transverse wave that I want you to know about. The crest. Where is the crest of a wave? At the very top. It's the highest point of the wave. So would this be a crest right here, guys?
Yeah.
Yes, that's a crest. Would this be a crest? Yes. And this one even says crest. So the top of the wave is the crest. Now, another part is called the trough. The trough is what? The bottom or the lowest point of the wave. So this is a trough, and also this would be a trough. Okay, examples of transverse waves are ocean waves. The disturbance moves up and down, but the wave travels perpendicular to that. Okay. Now let's look at longitudinal waves in a little more detail. Like it says, in longitudinal waves, the medium vibrates back and forth parallel to the direction of the wave. There's a couple of parts of a longitudinal wave that I want you to know about. The first part let's talk about is compressions. Compressions are regions where the medium is very compressed or dense. So right here you can see this is a compression. The medium is very dense. They're very close together. So that's called a compression. The other part is called a rarefaction. Say that, rarefaction.
Rarefaction.
Rarefaction. These are regions that's kind of exactly opposite of compressions. There are regions in the medium where it's not so dense. There's a lot of space. So this right here, this is a rarefaction. It's not so dense. It's kind of stretched apart. All right, so what's an example of a longitudinal wave that we would be familiar with? One of the best examples of longitudinal waves is sound waves. Okay, so let's look at how a longitudinal wave works. We talked about speakers last chapter, but the speaker works, this diaphragm here of the speaker moves back and forth, left and right. Well, the movement of that causes air molecules to be compressed. And so it sends out these compressions. So right here where they're very close together, this is a compression. In between compressions is rarefaction. So there's another compression right here. How do we interpret compressions and rarefactions as sound? How does that work? So these compressions are moving out parallel to the direction that this disturbance is happening. So it's moving this way. How do we hear it? Good. Yeah, the compressions are coming in and it's moving our eardrums back and forth, right?
Left.
Okay, so the eardrum is kind of moving back and forth with the compressions and rarefactions. And then how do we make sound out of that? Do you guys know how the ear works? Yeah, so there's three bones that are connected to the eardrum. Do you guys know what they are? The malleus, incus, and stapes. And those bones kind of move. And then it takes that movement and the nerve cells pick up on that movement and it interprets it into sound in the brain, right? And so all we're doing is picking up compressions and rarefactions in the form of a wave. So when you talk, your voice box does that. It compresses the air. There's these compressions and rarefactions that I'm sending out through the room, and you can hear people talking. Okay, summary. Let's summarize the differences between these types of waves. So we're talking about mechanical waves. There's two of them. There's transverse, and there's longitudinal. Okay, so let's contrast these for a second. Let's look at longitudinal right here. Longitudinal waves happen when there's a disturbance that's parallel to the wave motion. What do we call these areas where the medium is really bunched up? It's really dense. What do we call this right here, guys? This is a compression. This is a compression right here. What do we call this area where it's not so dense? Rarefaction. Okay, and then there's another compression. So that's a longitudinal wave. It's easy to show longitudinal waves if you draw dots. Okay? Now let's look at transverse waves. When the disturbance is parallel, so the disturbance or perpendicular, so the disturbance would go up and down, the wave would go parallel. What do we call this point of a transverse wave at the very top of the wave?
Crest.
That's called a what?
Crest.
Crest.
No.
And what do we call the bottom? Trough. I want you to notice, if you line up a longitudinal wave with a transverse wave, the crest lines up with which part of the longitudinal? The crest lines up with the compression. The trough lines up with what? The rarefaction. So there's another crest, another compression, another rarefaction, another trough. And so you can line them up. Okay. What do we call the distance between crest to crest? It's called a wavelength. That's how long the wave is. Can wavelength vary? Can it be different? Yes. How would you measure wavelength in a longitudinal wave? compression to compression. Okay. All right, practice problem number 2. We're going to try something here with a partner. So you're going to get with a partner, and I'm going to give you a slinky. And I'm going to have you demonstrate a transverse wave and a longitudinal wave. So if you're watching the video, unfortunately, hopefully you have a slinky or something to try this with at home. But we're going to try this in the classroom right now. So please hit pause and try this on your own. Okay, so hopefully you guys were able to demonstrate with a slinky a transverse as well as a longitudinal wave. And they kind of make more sense now. Practice problem number 3. Let's try this one. It says, to show the difference between the two types of mechanical waves, draw and label the parts of the transverse wave and the longitudinal wave below. So let's do that. So transverse, I want you to show right here, and a longitudinal right there. So let's try that. I'm going to give you some time. If you're watching the video, please hit pause. I want you to try to draw these. I will give you one hint. With the longitudinal, it works better if you draw dots. Longitudinal, it works better if you draw dots. Okay, so try that. And then I want you to label the different parts. Okay? So if you're watching the video, please hit pause and try that right now and see if you can't get it right. Okay, so hopefully you guys tried that. Let's see how you did. If I was going to draw a transverse wave, the disturbance is going up and down, but the wave is going out. And so transverse wave looks kind of like this. Okay? Now let's label it. Before we go to longitudinal, let's label this transverse wave. What do we call the tops of the waves, guys?
Crest.
Crest. What do we call the bottom of the wave?
Trough.
The trough. And what do we call the distance from one crest to the next crest? Yeah, this would be called a wavelength. Okay? Could I also measure wavelength from trough to trough? Yeah. Could I measure it from the middle to the middle? Actually, we should label this. What is the middle of this? There's an imaginary line that runs right here. What do we call that? This is called the origin. Yeah, the rest point or the origin of the wave. Yeah. Okay. So that's a transverse wave. Remember, the disturbance up and down, the wave goes perpendicular. Let's make a little note that the disturbance goes up and down. The wave goes perpendicular. Okay? Maybe put that in the margins or right by your transverse wave. Now let's draw a longitudinal wave. Like I said, it's easier to do with dots. So I'm going to draw a bunch of dots really close together. What is this part? Compression. Okay, and then I've got some dots here that are not so close together. Okay, and then again, there's another section right here where they're very close together. So let's label them. This is compression. Okay, and this area where it's not so dense is called what, guys?
Rarefaction.
A rarefaction. Okay, and then I misspelled wavelength right here. So let's fix that. Now, if I wanted you to find the wavelength of a longitudinal wave, where would you go from? Compression to compression. That's one wavelength. Could we also do it from the middle of the rarefaction to the middle of the next rarefaction?
Yeah.
Sure. Okay, and so let's make one final note. On a longitudinal wave, the disturbance goes in the same direction as the wave. So they're in the same direction. Okay, before I quit the video, before we end it, let's have a quick review. Waves, what are they, guys?
Disturbances.
A disturbance.
Which causes energy to be transported.
What are we moving? Energy. Are we moving mass? Do we have to transport the mass? No, but we're transporting energy. That's what's really cool about waves. Now, there's two main classifications of waves. What are the two main ones?
EM and
Mechanical and EM waves, or electromagnetic waves. We're going to save electromagnetic for the end of the chapter, but let's talk about mechanical. There's two mechanical waves we learned. What are they?
Transverse and the other one.
Transverse and longitudinal. Could you guys tell me the difference between them?
Yeah.
Okay. Could you also label the different parts of the waves? I hope so. Next time, we're going to talk about some wave characteristics. We're going to learn how to calculate all different parts and kinds of characteristics of the waves, like speed, wavelength, and frequency. But for right now, hopefully that was a pretty good introduction to waves. You know the different classifications and the different kinds.